Canny College is dedicated to empowering individuals to excel in their truck and transport mechanic trade through top-notch preparation courses for the Truck and Transport Mechanic Licensing Exam. Our online course is comprehensive and designed to equip you with the skills, knowledge, and confidence needed to pass the demanding Red Seal Trade License Exam and earn your Truck and Transport Mechanic Certificate of Qualification. We are your trusted pathway to success in the Canadian Red Seal Trades License Exams, a crucial milestone on your journey to a rewarding career in the skilled trades industry. Aspiring professionals seeking a Canadian Red Seal trade license can rely on our institution's expertise. Canny College offers comprehensive online exam preparation courses for various skilled trades. It uses an innovative learning approach and a commitment to excellence to equip students with the essential skills and expertise required to succeed in their chosen trades. Visit our website at www.cannycollege.com for more details. Please note that the practice questions provided here demonstrate the structure and phrasing of Red Seal examination questions. They are for study purposes only and do not result in certification or reflect actual performance on the examination. Question 1. What is done to test the pickup coil in an electronic ignition? A. Test coil at 60 degrees Celsius, 140 degrees Fahrenheit. B. Test the voltage with a voltmeter. Test the resistance with an ohmmeter. D. Remove the coil from the vehicle before testing. The correct answer is C. Test the resistance with an ohmmeter. Here are 4 reasons why. 1. Testing the resistance of the pickup coil with an ohmmeter can help determine if the coil has the proper amount of resistance within its specified range. 1. This can indicate whether the coil is functioning correctly or if there are any issues with it. 2. Pickup coils rely on changes in resistance to signal the ignition control module when to trigger the spark for the ignition system. 2. Testing the resistance allows for checking the integrity of the coil's internal wiring and connections, ensuring it can effectively send the required signals. 3. Using an ohmmeter to test the pickup coil provides a quantitative measurement of the coil's resistance. 4. Comparing the actual resistance value to the manufacturer's specifications helps in diagnosing any potential problems within the coil and can indicate if it needs to be replaced. 4. Testing the resistance of the pickup coil is a non-intrusive method that can be done without removing the coil from the vehicle. 4. This allows for a quick and efficient diagnostic procedure to evaluate the coil's functionality and identify any issues affecting its performance in the electronic ignition system. Question 2. When an electronic ignition switch is in the crank position, the engine starts. As soon as the ignition switch is released to the run position, the engine stops. What is defective? A. Spark plugs. B. Cap and rotor. C. Ignition switch. D. Spark plug cables. The correct answer is C. Ignition switch. Here are 4 reasons why. 1. The symptom described suggests that there may be an issue with the ignition switch itself. 1. When the ignition switch is in the crank position, it provides power to the starter motor to crank the engine and start it. 1. However, when the switch is released to the run position, it should continue to provide power to the ignition system to keep the engine running. 1. The fact that the engine stops as soon as the switch is released indicates a fault in the ignition switch. 2. The contacts within the ignition switch may be worn, corroded, or damaged, causing them to lose contact or break connection when the switch is released to the run position. 2. This interruption in the power supply to the ignition system can result in the engine stalling immediately after starting. 3. Electrical issues within the ignition switch, such as a short circuit or open circuit, can also lead to the described symptom. 3. If there is a partial or complete loss of electrical continuity within the switch when transitioning from the crank position to the run position, it can cause the engine to shut off. 4. Testing the ignition switch with a multimeter can help confirm if there is a fault in the switch. 4. By checking for continuity and proper operation during different switch positions, it can be determined if the ignition switch is defective and needs to be replaced. Question 3. What is done after installing a new accessory belt? A. Check the belt tension at the next service. B. Check the belt tension after running the engine. A. Ensure the top of the belt is fully recessed in the pulleys. D. Set the tension to 0 deflection to compensate for belt stretch. The correct answer is B. Check the belt tension after running the engine. Here are 4 reasons why. 1. Checking the belt tension after running the engine allows for the belt to properly and settle into place. 1. During the initial startup, the belt may stretch and adjust slightly, affecting its tension, so it is important to verify the tension after this adjustment period. 2. Running the engine provides the opportunity to observe the belt in operation and ensure that it is tracking correctly on the pulleys. 2. This can help identify any issues with alignment or tension that may not have been apparent during the installation process. 3. Checking the belt tension after running the engine helps ensure that the belt is properly tensioned for optimal performance. 3. Incorrect belt tension can lead to slippage, premature wear, and potential damage to other engine components, so it is important to verify the tension under operating conditions. 4. Verifying the belt tension after running the engine is a proactive measure to confirm the proper installation and functioning of the accessory belt. 4. This step helps preemptively address any potential issues or concerns with the belt's tension and alignment before they escalate into bigger problems. Question 4. An engine is running at 1,000 revolutions per minute. On a single-wire alternator, the output reads 12V and 0A. What is the cause? A. The battery is defective. B. One positive diode is open. C. One negative diode is open. D. The voltage regulator is defective. The correct answer is D. The voltage regulator is defective. Here are 4 reasons why. 1. The voltage regulator controls the output voltage of the alternator by adjusting the field current. 1. If the voltage regulator is defective, it may not be properly regulating the voltage, leading to a constant output of 12V even when there is no current flow. A. 2. A properly functioning alternator should adjust its output voltage based on the electrical load and system requirements. 2. In this case, the output voltage remaining at 12V even without any current flow suggests that the voltage regulation function is not working correctly, pointing to a fault in the voltage regulator. 3. The alternator's output should increase or decrease based on the electrical demand from the system. 3. A reading of 12V and A indicates that the output is not responding to the load changes, which can be indicative of a malfunctioning voltage regulator that is unable to adjust the output accordingly. 4. A defective voltage regulator can lead to issues such as overcharging or undercharging the battery, inconsistent voltage output, or erratic behavior of the electrical system. 4. In this scenario, the constant 12V output with no current flow suggests that the voltage regulator is not functioning as intended, resulting in a lack of regulation and control over the alternator's output. Question 5. What is the recommended ratio to use when replacing engine coolant with standard antifreeze? A. 30% water, 70% antifreeze. B. 50% water, 50% antifreeze. C. 70% water and 30% antifreeze. D. 75% water, 25% antifreeze. The correct answer is B. 50% water, 50% antifreeze. Here are 4 reasons why. 1. The recommended ratio of 50% water and 50% antifreeze is commonly referred to as a 50/50ths mix. 1. This specific ratio provides the optimal balance for engine cooling and freeze protection. 1. Water helps transfer heat efficiently, while antifreeze protects against freezing and corrosion. 2. Using a 50/50ths mix of water and antifreeze provides freeze protection down to a certain temperature, usually around -34 degrees Fahrenheit, -37 degrees Celsius. 2. This is important to prevent the coolant from freezing in colder climates, which could lead to engine damage. 3. The 50/50ths ratio also helps prevent overheating in warmer conditions by ensuring proper heat transfer and cooling capabilities. 3. Antifreeze raises the boiling point of the coolant, reducing the risk of overheating and coolant boiling under high temperatures. 4. Maintaining a proper balance between water and antifreeze in the cooling system helps prevent corrosion, rust, and mineral deposits from forming inside the engine and cooling system components. 4. This can prolong the life of the engine and cooling system, ensuring optimal performance and longevity. Question 6. Oil contamination is found in the secondary reservoir. What is faulty? A. Oil cooler. B. Purge valve. C. Turbocharger. D. Air compressor. The correct answer is D. Air compressor. Here are 4 reasons why. 1. Oil contamination in the secondary reservoir indicates that oil is being introduced into the air system, which is not a normal occurrence. 1. The air compressor is responsible for compressing air and can potentially introduce oil into the system if it is faulty. 2. If the air compressor is faulty, it may be allowing oil to leak into the compressed air, leading to oil contamination in the secondary reservoir. 2. This can be caused by worn internal seals or other components within the air compressor that allow oil to mix with the compressed air. 3. Oil contamination in the secondary reservoir can negatively impact the performance and operation of the air system. 3. Contaminated air can cause issues with downstream components, such as valves, actuators, and other pneumatic devices, affecting their reliability and efficiency. 4. Addressing the faulty air compressor is crucial to prevent further oil contamination and ensure the proper functioning of the air system. 4. Repairing or replacing the air compressor will help eliminate the source of oil contamination and maintain the integrity of the air system. Question 7. How is the fluid in a power steering system drained? A. By lifting and supporting the axle, disconnecting the pressure line at the reservoir, and then turning the steering lock to lock and capture the fluid. B. By lifting and supporting the axle, disconnecting the return line at the reservoir, and then turning the steering lock to lock and capture the fluid. C. By disconnecting the return line at the reservoir, then inserting the suction gun into the reservoir and capturing the fluid. D. By disconnecting the return line at the reservoir, then applying compressed air and capturing the fluid at the reservoir. The correct answer is B. By lifting and supporting the axle, disconnecting the return line at the reservoir, and then turning the steering lock to lock and capture the fluid. Here are 4 reasons why. 1. Draining the power steering system by lifting and supporting the axle allows for easier access to the components and provides more room to work on the system without obstructions. 2. Disconnecting the return line at the reservoir allows the fluid to flow out of the system easily without creating pressure or blockages. 2. The return line is where the fluid, after being used in the power steering system, returns to the reservoir for recirculation. 3. Turning the steering lock to lock helps to ensure that all the old fluid is flushed out of the system. 3. By moving the steering wheel from one lock position to the other, the remaining old fluid in the system is pushed out, allowing for a more thorough draining process. 4. Lifting and supporting the axle, disconnecting the return line, and turning the steering lock to lock is a common and effective method for draining the power steering system in a controlled manner. 4. This process helps prevent spills and makes it easier to capture and dispose of the old fluid properly. Question 8. What is the first step to test the function of an anti-lock relay valve, ARV? A. Check the anti-lock modulator between the ARV and the brake chamber. B. Check the ARV differential pressure by applying 10 psi to the service port. C. Build the tractor system air pressure to 120 psi and make several service brake applications. D. Install a T-fitting at the ARV service port and one delivery port and install a gauge in each. The correct answer is D. Install a T-fitting at the ARV service port and one delivery port and install a gauge in each. Here are 4 reasons why. 1. Installing a T-fitting at the ARV service port and one delivery port allows for the insertion of pressure gauges to measure the pressure differentials and verify the proper operation of the ARV. 1. This step provides a direct method of monitoring and diagnosing any potential issues with the valve. 2. Installing pressure gauges at both ports enables the simultaneous monitoring of the pressure levels entering and leaving the ARV. 2. Any abnormalities in pressure readings or discrepancies between the 2 ports can help identify if there are any blockages, leaks, or malfunctions within the valve. 3. Testing the function of the ARV by installing pressure gauges at the service and delivery ports is a standard procedure recommended for diagnosing problems related to the relay valve. 3. This method allows for precise measurement and comparison of pressure values to determine the functionality and efficiency of the valve. 4. Installing pressure gauges at the ARV service port and delivery port provides a visual indication of pressure changes and helps in assessing whether the ARV is properly regulating air pressure and functioning as intended. 4. This step is essential for troubleshooting any issues related to the ARV's operation in the braking system. Question 9. A drum with a maximum specification of 16.620 in measures 16.632 in a groove. What is done? A. Replace the drum assembly. B. Machine 0.012 in off the drum. C. Machine 0.024 in off the drum. D. Replace the brake shoes with thicker ones. The correct answer is A. Replace the drum assembly. Here are 4 reasons why. 1. The measurement of 16.632 inches exceeds the maximum specification of 16.620 inches for the drum. 1. This indicates that the drum has worn beyond its acceptable limit, and simply machining it may not be enough to restore it to within specifications. 2. Exceeding the maximum specification for the drum indicates significant wear and potential issues with the drum's structural integrity and braking performance. 2. Replacing the drum assembly ensures that a new, properly sized component is installed to maintain brake efficiency and safety. 3. While machining the drum to remove 0.012 inches may bring it back within the maximum specification, there is a risk that the drum may not maintain its integrity and performance characteristics after the removal of that much material. 3. It is safer and more effective to replace the drum assembly in this case. 4. Replacing the brake shoes with thicker ones would not address the primary issue of the drum being worn beyond specifications. 4. The thickness of the brake shoes is related to their wear and may be adjusted independently of the drum's sizing. 4. In this case, replacing the drum assembly is the most appropriate solution to ensure safe and effective braking performance.